Okay, hey everyone, this is factoring day 2 lesson. So today we're going to talk about GCF and difference of squares. Those are two different types of factoring, kind of like a special case type of factoring. Yesterday we covered factoring when it was 3 terms each. Now we're going to talk about some special cases and times there. Okay, so a couple things here. When factoring, there may be some cases when all terms may have a number or variable in common. When they have a number or variable in common, it's called a GCF, greatest common factor. Now, if this is the case, a number or variable that can be pulled out before, there can be a number or variable pulled out before you start factoring by grouping. Also, if the leading coefficient of the trinomial is a negative number, most oftentimes you want to pull out a negative one so that you can factor it a little bit more, a little bit easier. All right, Mr. Lippy is staring at me through the window right now, so if I laugh, I'm very sorry. Okay, so factor each trinomial. The first thing I want to take a look at is, what do these three things have in common? Okay, so they have a 3x in common. I hope we can all see that. A 3x in common. You pull out the 3x, which leaves us with an x squared plus 4x minus 12. Now, this is still part of our answer. That 3x is still part of our answer. And now I just want to factor this trinomial here, that 3 term inside there. So how do we do that? Just the same thing that we had done yesterday. Take a look at the negative 12. Factors of negative 12 that we'll add to get to positive 4. That's a 6 times a negative 2. That's 6 times a negative 2. 6 plus negative 2 is 4, so those are our factors. So this is a 3x. Again, that is still part of our answer. And now we create our two terms there. X positive 6, x minus 2. Again, those are interchangeable. These two terms are interchangeable. Their order doesn't really matter in this case because the commutative property exists here. So there is our answer. Again, you could FOIL this back out to check to see if you got the right answer, but just for time's sake, I'm going to keep going here. Okay. Pause here and see if you can get it. All right, so what do these all have in common? These three terms have in common, they all have a negative 4y. Now notice that I'm pulling out a negative. Why am I pulling out a negative? Because it's going to make my life easier in a second. I see the leading coefficient, the leading term here has a negative, and that's no good. I want to get that to go away. So to do that, I just pull out that negative. It's going to leave me with an x squared, a positive x squared, minus, now notice here, if I pull out a negative, it's like dividing it out. 4 divided by negative 4 is a negative 1, so I'm really not even going to write that. Well, I could. And then I'm dividing out the y, leaving just an x. And then a minus, again, 120 divided by negative 4 is negative 30. And the y gets pulled out front already. And now, again, I can just factor the inside. X, okay, so almost went straight to it. Factors of negative 30 that we'll add to get to negative 1, negative 6, and a 5. X minus 6, x plus 5. All right, so if x minus 6, x plus 5, that is my answer there. The whole thing is my answer. Please don't forget about that negative 4y. That's an important part right off the beginning. So this is just a unique case when it has a greatest common factor. It doesn't always happen. It's just kind of like if it happens, this is what you do. Another case like that is the difference of squares. Now, what is a difference of squares? A difference of squares is a polynomial where both terms are perfect squares. Perfect squares are 4, 16, 9, 25, 36. I could keep going forever and ever and ever, right? Two numbers that multiply together. And they must be subtracted from one another. That is extremely important because of the word difference. This is not a sum of squares. This is a difference of squares. This is a difference of squares. 2x times 2x is my 4x squared. 3 times 3 is my 9. Notice that they're subtracted from each other. So this is called a difference of squares. Now, this will be reduced down into 2x plus 3, 2x minus 3. The difference of two squares, a squared minus b squared, can be written in the form a plus b, a minus b. A plus b, a minus b. So basically, you take the square root of your first term, the square root of your second term, put a plus sign, put a minus sign. That's pretty much it. Let's practice it. Okay, so this is a difference of squares. How do I know? Well, I see 100x squared. 100 is 10 times 10. X squared is x times x. So 100x squared is a difference of squares. Minus 4y squared. 4 times 4 is 2 times 2. Y is y squared is y times y. However, I should have checked right at the beginning because look, this has a GCF of 4. Pull it out, I get a 25x squared minus y squared. Still a difference of squares though. I can still reduce it down. This is 5x times 5x. This is y times y. And look, I'm subtracting, so it's a difference. Square root of 25x squared, 5x. Square root of y squared, y. There's my answer. Oh, got my plus sign. One has to be a minus, one has to be a plus. There is my answer. Try this one. Okay. X to the fourth. This is x squared, x squared. This, 5y to the third, 5y to the third. So that means I have my two terms, x squared minus 5y to the third, x squared plus 5y to the third. There's my answer there. I'm going to go rogue here off the notes here, and I'm just going to make my own. You can do this one too, but I'm just going to. Whoop. All right, so I'm going to try this one. X to the fourth minus 16. Try to factor that down. I'm going to do this one, but try to do it on your own real quick. All right, now this will reduce down. X to the fourth, that's an x squared, right? And this is obviously 4 and 4. Okay, so we've got an x squared plus 4. You know what? You could put minus or plus first. It doesn't really matter. In my purposes here, I'll just do the plus first, and I'll show you why in a second. So I've got x squared plus 4, x squared minus 4. You may think, oh, I'm done. However, that is still a difference of squares. So to reduce down, I leave this first term. Notice that you don't do anything to that first term. Why? Because it's a plus sign in the middle. It's got to be a difference of squares. I've got an x minus 2 and an x plus 2, and that is my answer. Remember, you can always FOIL to see whether you got the answer right. So I hope that teaches you a little bit about difference of squares and GCF. I'm going to stop the recording. Bye.